This chapter concerns with circles. So we'll learn certain terms that we may have to use in this chapter. First is the perimeter of a circle. Now the perimeter of the circle is this border here. And this perimeter of the circle is its circumference, which can be also called perimeter, and that is 2 pi r, where r is the radius of the circle. Next is perimeter of a semicircle. So this is a semicircle, which is half a circle, and you know this arc will be 2 pi r divided by 2, because 2 pi r is the entire circumference and this is 2 pi r divided by 2, which is pi r. But to that also we need to add this segment, which is 2r. It is a diameter, and the diameter you know is 2r. So when you are finding perimeter of semicircle, it is pi r plus 2r. That would be the perimeter of a semicircle. Next we do perimeter of a quadrant. Now a quadrant is a quarter of a circle. So if this is a full circle, the quadrant will be the quarter of it. So you have to mark it right from here to here. This will be the quadrant. And we need to erase this up. This is the full circle. This will be the quadrant. And the area of this, the length of this green part will be of course 2 pi r, which is a full circle, divided by 4. So it will be pi r divided by 2. But we are not done. This quadrant has got one radius and another radius, r and r. So to find the quadrant of the perimeter of a quadrant, it will be pi r divided by 2 plus 2r. This will be the perimeter of a quadrant. 1 r, another r here with the perimeter. So just to repeat, this perimeter is pi r divided by 2 and r plus r. That would be the perimeter of a quadrant. Next we will learn area of a sector. To learn area of a sector, first we see what is a sector. So every circle has got a center. So we mark the center here, and from this center we draw 2 radii. So we mark the center as O. So we have OA and OB, two radii. This area here is called the sector. So if I were to define a sector, it would be a region bounded by one radius, another radius, and you know that this is an arc. Here is the arc. There's one radius here and another radius here. So the area, or the sector of a circle is area bounded by an arc with 2 radii. And to find the area of the sector, the formula is given as theta over 360 pi r square. So what is theta? Theta is this angle associated with the sector. It could be 30 degrees, 60 degrees, 45 degrees. So this angle is theta. Every sector is associated with an angle at the center. It's called the central angle. So the area of the sector is theta by 360 into pi r square. Of course, the r you know is a radius. But remember, here you have 2 sectors. In fact, this is called the minor sector. We call this the minor sector. And on the other side, we will have the major sector. Again, we have the arc. It's a major arc, it's a larger arc. the arc with the two radii. So this area will correspond to the major sector. So this shaded region is the major sector. So if you define what is a major sector, is a sector whose area more than a semicircle. Area is greater than, more than area of semicircle. And minor sector area is less than semicircle. And for this sector, its area, the area is the same, theta by 360 pi r square. The area will be of this major sector will also be theta 360 pi r square. But the theta for this case is going to be here. This is the theta. The radius remains the same because it's the same circle. This is the radii of the circle, and this is theta. So you know what is major sector and you know what is minor sector. And the formula for area of sector, theta over 360 pi r square. Next we will see what is a segment. So to draw a segment, I first mark 2 points on the circle and I join them, so I get a chord. AB is a chord, and I have a chord, and this is the, of course, is the arc, and the area enclosed between this chord, not chord, this is the arc. The area enclosed between the chord and the arc is called segment. So here is the segment, this area. So if I were to define the segment, is area enclosed between a chord and arc of a circle. Here too we have the minor segment and the major segment. This is the minor segment. And for minor segment, area is less than semicircle. And on the other side we have the major segment. So this is the major segment. Again, it is also enclosed by a chord. This is the chord AB, and the arc. This is the major arc, however. This is the arc. So this blue region colored is the major segment, whose area, you'll definitely agree, is more than the semicircle. Find the area of a sector of a circle with radius 6 centimeters and the angle of the sector is 60 degrees. Let me draw the figure. So a sector is something like this with 2 radii and a arc. So this is the sector. Now they said the radius is 6 centimeters. So here the R is 6 centimeter and the angle of the sector 60 degrees. So this angle here is 60 degrees. However, this is a part of a circle, you know. This is the entire part of a circle. We are going to find the area of the sector. Now formula for area of sector equal to theta by 360 pi r square. In this case, our theta is 60, which they have given, 360 pi 22 by 7. The r they've given is 6, so 6 into 6. And when you work this out, you get it as 132 by 7 centimeter square. Why centimeter square? Because this is area. So area of sector equal to 132 by 7 centimeter square. You need to write here though that radius equal to 6 centimeter, Angle of sector equal to 60 degrees. And what basically we have done, we have found this area, the area of the sector, where this was given as 60 and the radius was given as 6. Find the area of a quadrant. Remember, quadrant is quarter of a circle whose circumference is 22. So in this they have given you circumference of circle equal to 22 centimeter. Now circumference is 2 pi r equal to 22. We'll put the values. 2 pi is 22 over 7. The r we don't know, and this is 22. Now we can find the r. So r equal to 22. This becomes 7 over 22 into 1 over 2. So the radius in this case now becomes 7 by 2 centimeter. But we are not done with the sum. We need to find the area of the quadrant. So area of quadrant is a quarter circle, means quarter of area of circle, quadrant quarter, which means 1 by 4, and area of the circle pi r square. I'll do it up here. So 1 by 4 pi 22 by 7. The r is 7 by 2 the whole square. Right, and on working this you get the answer 77 by 8 centimeter square. So you can write area of quadrant equal to 77 by 8 centimeter square. The length of the minute hand of a clock is 14 centimeters. Find the area swept by the minute hand in 5 minutes. So here's a clock. You know it has got 3 hands. So here we're dealing only with the minute hand. So if the minute hand is in this position, after 5 minutes it will be in this position. So the area swept will be from 12 to 1 in 5 minutes. So this would be the area swept. And if you can look here, the area swept will be that area of a sector. So basically we need to find here area of a sector. So we write here area swept by minute hand in 5 minutes is equal to area of sector. Now area of sector, the formula theta by 360 pi r square. Now the radius of the sector will be equal to length of the minute hand. If we were to mark it in the figure, here is the minute hand, which is 12 centimeters. Is it 12 or 14? Is it? It is 14 centimeters. So the radius we know is 14. So r equal to 14 centimeter. The question comes to find out the angle. This is the theta. We need to find the theta. Find the angle swept in 5 minutes. To find out the angle swept in 5 minutes, first we'll see what happens for the minute hand in 1 hour. In 1 hour, it is at 12. Then after 1 hour, it moves right round and comes back at 12. So in 1 hour, it sweeps 360 degrees. This is 360 degrees. This whole thing that it sweeps. This is 360 degrees. So 1 hour is 60 minutes. In 60 minutes, the minute hand sweeps 360 degrees. Therefore, in 1 minute, it will sweep 360 by 60, which is 6 degrees. And we need to remember this. In 1 minute, 6 degrees. Our question here is of 5 minutes. So 5 minutes, angle swept by minute hand equal to 5 into 6. That is 30 degrees. So our theta is 30 degrees in the sum. So to go back to our sum, we see the angle here in 5 minutes is 30. So to find area of sector is theta 360 pi r square. So theta we see is 30. We have calculated the 30 here. 360 into pi 22 by 7, and the r was the length of the hand, which was 14 square. If you work this out, you get 154 over 3 centimeter square is the area swept in 5 minutes. So in your answer, you need to write it in words. Area swept in 5 minutes is 154 over 3 centimeter square. In this sum, this is very important. These steps are very important. In 60 minutes, it sweeps 360. It takes a full circle in 1 hour. Therefore, in 1 minute, 360 plus 60, that is 6 degrees. This remains standard for a clock. Every 1 minute, it sweeps an angle of 6 degrees. Now for the fourth sum, a chord of a circle of radius 10 centimeter subtends a right angle at the center. So the figure is given here. This is our chord AB, and this chord AB subtends 90 degrees. So when you join to the radius OA and OB, the angle here is 90 degrees. That means AB subtends 90 degrees at the center. Here they say find the area of the minor segment and the major sector. First we'll go on to the major sector. We'll find the area of major sector. We know area of sector, remember this is major sector, is theta 360 pi r square. Let's mark the major sector in this figure. Now major sector is area more than semicircle. So major sector will be this arc. Area enclosed between this major arc and the two radii. So this is the area that they're asking us of the major sector, this entire area. To find the area of this major sector, we need to know the central angle and we need to know the radius. Now the central angle for this sector will be this, not 90, it will be here, this angle. And this angle you will definitely agree is 360 minus 90, which is equal to 270. So the central angle is 270 degrees. The radius was given as 10 centimeter, so we radius 10 centimeter. Now we put our values. So again, the theta is the major sector, so the theta is 270. 360 minus 90 over 360. Pi, they said, has to be taken 3.14. Your r is 10 square. And on working this out, you will get it as 235.5 centimeter square. And this would be the area of the sector, major sector. Next, we need to find the area of the minor segment. Now remember, see the difference. This is segment. We now have to find the area of the minor segment. The minor segment will be chord with the arc. So we need to find this area. But to find this area, in our first step, we will first find the area of the sector. So here is the sector AOB. So step 1, we find area of sector. And you know area of the sector formula, theta over 360 pi r square. In this case, the theta is 90 and the r is 10 centimeter. So we'll put your values here, 90 over 360. The pi is given as 3.14, r square 10 square. And this area of the sector works out as 78.5 centimeter square. This is area of sector. What have we found out is this entire area. But that's not what we want. We want area of the segment. Now to get the segment from here, what we need to do, from the sector, we need to subtract this area. Let me mark it in this figure. This area has to be subtracted. And once we subtract this area, then what remains behind is the segment. So in the next step now, I'm going to find the area of this triangle. So step 2, we need to find area of triangle. Now we know area of triangle is half base into height. In this case, we can take our base as OA. Here OA will be the base. It's a right angle triangle. And our height will be OB, because the angle between them is 90 degrees. So we'll have half our base, you can take OA, and height OB. So area of triangle is half into 10 into 10, which is 50 centimeter square. So this area we now have found out is 50 centimeter square. Now we are ready to find the area of the sector. And from the figure we saw the area of the segment. Area of segment equal to area of sector minus area of triangle. To explain it again here, see, this is a sector, and from the sector, if I remove this triangle, I subtract the triangle, what I'm left with, area of the segment. And that's exactly what I'm doing. So area of sector we found as 78.5, and area of triangle we found it as 50. And when you subtract, it gets 28.5 centimeter square is area of segment. So remember, whenever you have to find area of segment, you need to find two things. First, you have to find the sector, the entire sector, by using the formula theta by 360 pi r square, and then we have to find the triangle in step 2, and then subtract both of them, and you'll get area of segment. In a circle of radius 21 centimeter, so this is 21 centimeter, an arc subtends an angle of 60 degrees. So let's mark an arc. To mark an arc, we need 2 points A and B, and then when we join them, we get this arc. And this arc subtends, they said, 60 degrees. So here, if this is the center, this angle will be 60 degrees. The arc subtends 60 degrees. Find the length of the arc. Now, formula for length of the arc, in this case, length of arc AB, this is arc AB, is theta 360 2 pi r. Now in this case, we know the theta is given as 60, as we have written here. So we have 60 over 360 to 22 over 7, and we know the r here is 21. They have given 21. radius is 21. So length of arc AB, when you calculate this, will be 22 centimeter. Next we have to find the area of the sector formed by the arc. So we knew our arc was, this was point A and say B here. So this was AB, and this was the sector form, this was O, and this is the sector form. So we need now to find the area of the sector. And for area of sector, we have theta 360 pi r square. Now what is the theta in this case? They have already told you that theta is 60 degrees. And the r is given as 21. So all you need to do is just substitute theta 60 over 360, 22 over 7, r square, 21 square. And you work this out, you get the answer 231 centimeter square is area of sector AOB. Next we need to find area of segment, and we have to follow the 3 steps. So this is a segment, this is the area of the segment that we need to find out. So in step 1, like we did earlier, we need to find area of sector, which is theta 360 pi r square. So the sector here is OAB. It is given to us that this angle is 60 and the radius is given as 21. So let's put the value. So 60 over 360, your pi is 22 over 7 r square, 21 into 21. On working this out, you get 231, that is area of sector. Now we need to find area of the triangle. This is a triangle OAB. We need to find the area of this triangle. So step 2 is to find area of triangle AOB. Now we cannot use half base into height here because the angle is not given 90, but instead they have given the angle as 60. So this is 60, but we know OA equal to OB. If OA equal to OB, angle A and angle B must be X and X. So let's write that. OA equal to OB, therefore angle A equal to angle B equal to X. Angles opposite equal sides. So in triangle AOB, there are 3 angles, that is X plus 60 equal to 180. And if you work this out, your X also becomes 60, which means all the angles here are 60. This becomes an equilateral triangle. So to go over this up again, we did OA equal to OB, therefore angle A equal to B equal to X, and in the triangle AOB we have 3 angles, that is X plus X, so I just may write down X and X, plus 60 equal to 180, and we got X as 60. So here I have 60 and this is 60. So triangle AOB is equilateral. All the angles are equal. And for an equilateral triangle, the area can be directly found out. So triangle AOB, we use the formula root 3 by 4 side square. So root 3 by 4. And the side of this triangle is the radius, which is 21. So this is root 3 by 4, 21 square. This is the area of AOB. So this area is now root 3 by 4 into 21 square. Now that we have found the area of the sector and the triangle, we can now find the area of the segment. Now if you note look up in the figure. Here we have the segment, and this segment, right up here, area of this, we have the sector. The area of the sector is equal to area of the triangle, this triangle, plus area of this segment. Now we put the values that we know. We know area of sector we found as 231. Area of triangle is root 3 by 4, 21 square, which is 441. And our question is to find area of segment. So area of segment will be triangle, that is will be sector, that is 231 minus triangle, root 3 over 4, 441. This will be area of segment. So whenever we want to find area of segment, it's always equal to area of sector minus area of triangle. So in this sum, area of segment is 231, which is the sector, minus 441 root 3 over 4, that is a triangle, centimeter square. A chord of a circle of radius 15 centimeter subtends an angle 60 degrees at the center. So we need to draw the chord first. So here A and B. So this is A and B, and if this is the center of the circle, here will be our chord AB, and this chord subtends an angle of 60 degrees. So here this is the angle it subtends, and this angle is given as 60 degrees. First we have to find the area of the minor segment. Now the minor segment is this area, and we know how do we find area of segment. We just have two steps to find area of segment. First step, we find area of sector by using the formula theta 360 pi r square, and in the second step we find area of triangle, and in this case, because it is 60, it will be an equilateral triangle, but we need to prove it's an equilateral triangle. So let us go to the first part, is to find the area of the sector. So the area of the sector, this is the sector, here is your sector, this entire, we find to find the area of this entire sector, and area of the sector we know theta 360 pi r square. Here the theta is given as 60, they've given to us 60 degrees. The r is given as 15. So when we put our values, it will be 60 over 360. The pi, remember, has to be taken 3.14. R square is 15 square. So area of sector equal to, we need to solve this, it will be 1 by 6, because 60 over 360 is 1 by 6, into 3.14, and 15 square 225. On working, we will get 117.75 centimeter square. So this step is done. Now we need to do the next step, means we need to find the area of the triangle. Here is a triangle, we mark it OAB. So this area we need to find. We can't use half base into height because no 90 degrees is given. But there's one thing given to us, is this angle is 60. The central angle is 60. And in this triangle OAB, we know OA equal to OB because they are the radii. If the OA equal to OB, so angle A will be equal to angle B, which is equal to X. So let me mark that here. This will be X. This angle also will be X. Now we use angle sum property. That means X plus 60 equal to 180. And your X comes as 60. Let me continue it here. Therefore, triangle AOB is equilateral because all the angles are 60. And area of equilateral, we know the formula is √3/4 side square. So this will be √3/4. Now the side in this case is the radius, that is 15, 15 and 15. So this is 15 square. So now we know the second step too. We know the area of the triangle. Now all we need to know is subtract the two to get the area of the segment. So now this was AOB. We found area of sector, this entire sector. So area of sector AOB is equal to 117.75 centimeter square. Now from there we need to subtract the area of this triangle, of triangle AOB. So we have triangle area of AOB, that is a triangle AOB. And that area of triangle AOB, it was an equilateral triangle. We got it as √3/4 side square. So √3/4 side was 15 square. And on working this, you got 97.3125 centimeter square. So area of triangle. Now after we subtract, what will remain? If we subtract from the sector, if we subtract this triangle, what will remain is the segment. So now to find this area of this segment, area of segment, we need to do area of sector minus area of triangle. So sector 117.75, triangle 97.3125, and the answer then comes is 20.4375 centimeter square. This is area of segment. Now remember, there are two segments. One is the minor and the major. What we have found is minor segment. This is minor segment. Now we need to find area of major segment. The major segment is this entire area. So this is our major segment. And you'll definitely agree, major segment will be the whole circle. This entire area of this entire circle minus the minor segment. Minus this minor segment will give you area of major segment. So this entire circle here we see is made up of two parts. It's made up of this minor segment plus we'll mark this as a major segment plus this area, the whole circle. Right? You add up both these and you'll get area of the circle. Now area of the circle would be pi r square equal to, we do not know the major segment. We need to find, that is our question. A minor segment, however, we have already found out as 204,375. So 204,375. Now to find the area of the circle, pi r square, that is 3.14, and we know the r in this case is 15, so this will be 15 into 15, area of the full circle. The major segment we don't know, and we need to find that major segment equal to major segment plus minor segment. So area of circle, on calculation, area of circle will be 706.5 minus the minor segment, which is 20.4375, will be equal to major segment, and on calculation you will get 686.0625 centimeter square is major segment. So to repeat the sum, if you know, suppose you have the circle, and if you know the area of this minor segment, how will you find the area of this major segment? The area of this major segment will always be area of circle minus area of minor segment, and that is what we have done. Area of major segment equal to circle minus minor segment. Why is that so? Because the whole circle, area of circle, is made up of area of major segment plus area of minor segment. The circle is made up of the major segment and the minor segment. A horse is tied to a peg at one corner of a square shaped grass field of side 15 centimeters by means of a 5-meter long rope. Find the area of that part of the field in which the horse can graze. So the horse is now tied with a peg here, and the rope is 5 centimeters. So although there is so much of grass, he cannot reach the entire field. He will be able to reach only this area. Because he's been tied with 5 centimeters, this is the area is available for the horse. And the area available for the horse will definitely agree is the area of a sector, which will be theta 360 pi r square. Now what is theta here? Here it is a square, so the angle here is 90. So for theta you will put 90 over 360, the pi of course 22/7, and the radius will be the length of the rope by which he is tied. He is tied by this rope. He is tied only by a rope of 5 centimeters. That is why his limited area where he can graze. So r is 5. So this is 5 square. So this is the area available for the horse to graze. Although there is so much more area, he is unable to reach the other area because he has been tied with a rope of 5 meter. And when you calculate this answer, you will get, of course, I think you have to put pi, it should be put, I made a mistake here, not 22/7, it is to be put 3.14. And r is 5 square. On calculation of this, you will get 19.625 meter square. So here, of course, you need to write area of grazing for the horse is equal to area of sector, where theta 90 and r is 5 centimeters, that is the length of the rope. This is one part of the sum. Then the second part of the sum says, find the increase in the grazing area if the rope were 10 meter long instead, Now they're giving him a longer rope. A longer rope means he can now graze more area, 10 centimeters. This probably would be the area he would graze, this entire area. A longer rope is now he can go further up. So for the second, new area is also equal to area of sector, which is theta 360 pi r square. The theta remains the same, 90 degrees, because it is a part of a square. So you put 90 over, you have 360, pi is to be taken 3.14, and the r now is 10 because he's tied with a rope of 10 meter long. So 10 into 10. And on working this out, you will get the answer as 78.5 meters square. And we have to find the increase in area. If you remember, this was the old area of 19.625. Now he can graze in 78.5, more area. So the increase in grazing area will be equal to the new area, which is larger because the rope was made longer, minus the old area. And the new area is 78.5. The old area was 19.625. And on subtracting, you'll get 58.875 centimeters square. So increase in area equal to 58.875 meter square.